Hello students, welcome to Fun Scholar. So today we are going to discuss the topic lines and angles. This is for class 9 CBSE board, but it will be also beneficial for ICSE board students as well. Okay, so let's start. Okay, so lines and angles. There are two topics which we will be discussing in this chapter, and there are types of lines and types of angles we will be discussing. Okay, so let's start. Okay, so here is a video, but you generally know that I don't like to play much videos in my live sessions. So what is a line? We generally all know it, and we have already studied this in class 6 and 7 as well. Okay, so this is a line. This is a line. Okay, maybe this is not a completely straight line, but we can call this is a line. Okay, so So can you tell me where do we see lines and angles in our class? Okay. One kid is asking another, and the another kid is replying board, bench, scale, room, all we have lines as their sides and have right angles. Okay. So if I generally used to give example that this is a line obviously and this is an angle. Okay, so if you wherever you are watching this video, just turn around and used to see there will be so many kind of lines and there will be so many kind of angles everywhere. Okay, so in general, in reality, we have to see lines and angles everywhere. Okay, next, so types of line. First, first one is intersecting lines. And talking about intersecting, okay, let's see all the types of lines. So first one is intersecting lines, second one is non-intersecting lines, and there will be a third type of lines that are concurrent lines. Okay, so first example, intersecting lines means this one will be intersecting lines, okay, or this one will be intersecting lines, or this type of line is also a type of intersecting lines. Okay, and non-intersecting lines means these type of lines are non-intersecting lines. And talking about concurrent lines, we will discuss it later. What are the concurrent lines? Yes. Okay, so line infinitely many points arranged straight one beside the other gives line. Okay, that means if I draw a line like this, if I draw a line like this, so that means I am arranging so many dots and joining it in a random manner. So this will give us the definition of line. Okay. So line extends in both directions and has no endpoint. Okay. Maybe you guys are assuming that why it has two arrows in it. Okay. And why generally when we are talking about line, we generally draw lines like these all are lines, but here they are indicating it with two arrows in each side. So why this is? Because generally we call line as line segments, or line segments are generally called by the term line. And what is the difference between line and line segment, which we will also, maybe you have also learned it in class 7 or 6, but we will discuss it in further. So basically line means these type of things. Okay, that means which will be extended into the both part. And line segment means if we cut it a small or bigger part from this, that will be called as a line segment. Okay, so this is the, I mean, general difference between line and line segment, but in general, we generally used to call line segment as lines. Okay. So this is also like a line or line segment, whichever you guys can consider, and lines can be extended in both direction. That's why we have used it with two arrows. Okay, so these are very much basic knowledge. So next, okay, now comes to ray. Infinitely many points arranged straight one beside other form a starting point gives ray, just like this. Okay, like I have already told about lines, that if I draw so many points and join it in an arranged manner, it will give me the line. The same way, if I draw so many points and join it with the arranged manner, it will give me ray. But difference between ray and line are that lines can be extended in the both side, but ray can be extended in another, in just one side. Okay, so that means this one will be a ray for this side. Its starting point is this. This one will be a ray and its starting point will be this, and it will be extended in this side. This one will also be a ray and it will extend to the this side, and its starting point is this. Okay, so let's go next. So ray is basically, you have already studied it in class 7 in 6. Okay, next. So ray starts at one point and extends in another direction. Okay, which already we have studied. Okay, it has only arrow in only one side. Okay, not both sides. This side it doesn't have any arrow. Okay, let's go next. Line segment, and I already told it before, that line and line segment differences. So infinitely many points adding straight one beside the other of certain length gives a line segment. Okay, and its figure will look like this. Okay, it won't have arrows in the both sides. The next that is, we will learn about the collinear points. Okay, so before learning about the coplanar points and lines, so let's watch a video. I generally don't play so many videos, but this video is important, so let's see it. In the previous video, we looked at collinear points. In this video, all we have to do is visualize points, lines, and planes. If we have 3 points, A, B, and C, and exactly one line passing through all of them, then they are called collinear. The correct definition says that 3 or more points are collinear if a line passes through each of them. Now consider these 3 points, P, Q, and R. Since we do not have one line that can pass through points, they are not collinear. There is some expression you need to know about 3 non-collinear points. Exactly one plane will pass through the 3 of them. It does not matter whether points lie. One plane will pass through any 3 non-collinear points. Now consider this table which has a plane surface. Here we have 4 points, P, Q, R, and S on it. Basically, points P, Q, R, and S lie on the plane. What do we call the points that lie on one plane? They are called coplanar points. Remember, 3 points will always be coplanar. 4 or more points may or may not be coplanar. Planar means on one plane, and co means together. With 4 or more points together on the plane, they are called coplanar points. This is the line N, point P, which is not connected. Think about it. Will they lie on one plane? Yes. These two also will form
you call lines L and N? Yes. If they lie on one plane, they will be called coplanar lines. So if we have a plane and two lines, say line L and line N, then lines L and N are called coplanar lines. Are two lines always coplanar? No, not necessarily. This is a plane surface and line N lies on it. There can be another line O which passes through the plane and does not lie on it. In such cases, lines N and O are called non-coplanar lines, as both of them do not lie on one plane.
Okay, so we have learned that collinear points, that if there are two or more points lies in one line, so we will be calling them that collinear points. Okay, and if two or more lines stays in one plane, so we will be calling them coplanar lines. Okay, so this one is just a small video about collinear points and coplanar points. So now it will be easier to understand about this. Okay, so this is an example of collinear points, because A, B and C, there are 3 points which is lying in one line, and these points like P, Q, R will be non-collinear points because it won't be having one line. Okay, if I draw lines like this, so P to Q will be one line and Q to R there will be one line. Okay, so that's why they are non-collinear points. Okay, so let's go next, and we have already learned about the collinear points and non-collinear points, and these are L and M are the coplanar lines because they are lying in one plane. Like if I draw so many lines like this, if I draw so many lines like this, they all will be called as the coplanar lines because they all are lying in one plane, that is this whiteboard. Okay, so let's go next. Okay, so what are intersecting lines? And we already have discussed a little about it, that these type of lines will be called as the intersecting line, and this will be called as the intersecting point. Generally people give names like P, Q, O, these are the names. Okay, and L and M are two different lines which are intersecting at point P, Q or O. Okay, so done it. Now let's know the definition of intersecting lines. Two lines are said to be intersecting if they meet at any point. Okay, just like this, and two straight lines cannot meet at more than one point. Okay, so if I elaborate this statement, so two lines cannot be met more than one point. Okay, here is the one point, so two lines can't meet at two or more points, so that won't be called as the straight line. Like this line is straight and this line is not. Okay, so if this is a straight line, that will definitely meet at one point, and if that is not a straight line, it will be meeting at so many points. Okay, let's go next. So in how many ways can three lines intersect? It has a video, so let's not play it. Okay, and you guys can generally think that how many ways can three lines can be intersect. Like if I draw three lines like this, 2, 3, or 1, 2, 3. So there will be so many ways where three lines can intersect. Like it has intersect in 3 points, it has intersect in 2 points, and there will be so many types of points which you guys can generally figure out. Okay, let's go next. Okay, and so it is a demonstration that what was the video was be like. So you guys can see that there are 1 point, 3 points, 2 points, which I have already told that 3 lines can be intersect in so many type of points. Okay, which are the different types of angles. Now come to the angles. Okay, and if I generally talk about angles, so anything when two rays meet at one point, they make an angle. Okay, like this angle, and we generally note it like a curved line. Okay. Okay, and types of angles. Now learn about types of angles. Angles definition already been like revised. Now there are three types of angle, that is acute angle, right angle and obtuse angle. Okay, so for a little information, people generally mistake angles with triangles. Okay, don't make mistake. There are six type of triangles which are three by side and three by angle, and there are only three types of angles like acute angle, right angle and obtuse angle. People generally make mistake like acute angle triangle, right angle triangle and obtuse angle triangle. Triangle is different thing and angle is different thing, which makes a triangle, acute angle, right angle and obtuse angle is these type of angles. Okay, so don't make mistake there. Okay, and there are already two or three more types of angle like straight angles, reflex angle, complementary angle, supplementary angle. Okay, full angle or round angle. There are so many types of different angle, but main three are like this, which generally use the measurement of angle to categorize them. Okay, so an angle is formed when two rays originate from the same point, which we have already discussed. These two will be called as the arms and this one will be called as the vertex. Okay, next, the rays making an angle are called arms of the angle and the common points is called vertex of the angle. Okay, vertex is the common meeting point and these two are the arms. Okay. Now, what is the angle between two hands of a clock when the time in the clock is 9 o'clock? So, these are general questions which are the practical examples where angles can be found. Like in 9 o'clock, these will be the angle. Okay, and we have already learned about it. Now, tell me that what will be the measurement of this angle? Generally, it will be the 90-degree or the right angle. Okay, so in a clock, in a wall clock, the 9 o'clock will be the right angle or the 90 degree. Okay, so it's been done. Now try to tell me about this, that what is the angle between two hands of a clock when the time in the clock is 6 o'clock. So you can measure the angle like for this side or like for this side, both will give the same value, and that is a straight line or a straight angle or 180 degree. Okay, maybe you already have guessed it better. Let's go to the next. Okay, what is the angle between two hands of a clock when the time is the clock is 7 p.m. It's, you have to tell it, you guys have to tell it, it's 7 o'clock and the angle is this. So when there is the time 9, that is 90 degree and it's being like this, so it will be 90 plus 30, 90 plus 30, that is 90 plus 60 and that will be 150. Okay, you guys can measure it, and in generally in GA classes you have to remember that each time will having 30-degree angle in each. Okay, so when we'll be discussing the sums, we will discuss it in a proper manner. Okay, so let's just try to understand that the time will be or the measurement will be 150 degree. Okay, let's go to the next. Okay, so acute angle, angles between 0 and 90 degree are called acute angles. Okay, from 0 degree to 90 degree, all angles will be called as the acute angle, like 45 degree or 60 degree or 89 degree, all will be called as the acute angles. Okay, let's go next. Example are this. Okay, and it will be, and the image will be like this, like if I take this, they all will be considered as the acute angle, as the L is the right angle and all angles lower than this will be called as the acute angle. Okay. Okay. Now come to the right angle, and I have already told about the characteristics of it. Angles which measures 90 degree is called as the right angle. Okay, it has a confirmed measurement, that is 90 degree, and it will be measured like this, and the angles will look like this. Okay, by this side or this side. Okay, it will be look like L and the measurement will be 90. Okay, next, angles between wall and floor. Obviously right angles are very much abundant element, like for like this screen everyone is making a right angle. Okay, everyone is making a right angle. Okay, everyone is making a right angle. Now come to the obtuse angle. That is angles more than 90 degree but less than 180 degree will be called as the obtuse angle. Like we have already discussed the right angle and acute angle. But which will be bigger than this? Like for like this angle, and they are all bigger than the right angle will be called as the obtuse angle, and its measurement will be bigger than 90 degree and smaller than 180 degree. So from starting from 91 degree and last 179 degree will be called as the obtuse. Okay, so these are the examples and the image will be looking like this. Okay, so, and there comes the straight angle. Angle that forms a straight line is a straight angle. We already have discussed about this in the clock sum. Like for like any straight angle will be, any straight line will be called as a straight angle. Okay. Any points on straight line shows straight line. Okay. Next, reflex angle. So angles more than 180 degree but less than 360 degree will be called as the reflex angle, and the image will be looking like this. Like if I draw an angle like this, if I draw an angle like this whole angle will be called as the reflex angle. Okay, so in general, reflex angles are the opposite of acute angle. Like if I draw an acute angle like this, so the part which are not forming an angle will be called as the reflex angle. Okay, in general, in our protector, we don't have the option to draw a reflex angle, but if you go higher, especially in geography, reflex angles are very much popular thing. For that, you have to get a total round protector or 360-degree protector. Okay, so we'll discuss it later. So these all are the examples of an reflex angle or how an reflex angle looks like. So in general, so in this figure you can see that all the angles are being used like this, like right angle, obtuse angle, acute, straight and reflex, all of that. Okay, now let's watch a video like for this all the summary. So in this video, here is the all summaries that which we have already studied, that all the types of angles.
To understand the types of angles, we need to understand just one simple diagram. Consider a ray OA. We know that if this ray is rotated completely once, it covers 360 degrees. All the different angles which lie in between 0 and 360 degrees are classified into types. There are two kinds of important angles we come across very often in mathematics. First kind is an angle like this, and it covers 1/4 of the 360 degrees rotation. Let's call this ray OC. This angle from here is called a right angle, and since it covers 1/4 of the 360 degrees, it measures 90 degrees. This angle is special in many ways. It is the only angle which is not marked with a curve. Normally, angles are marked like this, with a curve between its two arms. A right angle is marked like this. With this mark, we don't even need to write the measure next to it, since these two lines are enough to tell you that it's a right angle. And when the angle between two rays or lines is 90 degrees, we say they are perpendicular to each other. The next important kind of angle you will see often is called a straight angle. The name says it all. The arm is rotated in such a way that a straight line is formed like this. Let this arm be called OE. This angle formed here between OA and OE will equal 180 degrees. It is called a straight angle. And this straight angle covers half the complete rotation, which is 180 degrees. So remember, 1/4 of the complete rotation is a right angle, and half the complete rotation is called a straight angle, which is actually a straight line. These two were the special angles, and if you look at the figure closely, these two angles divide the plane into three regions. Let me color them for you. This blue region, which is between 0 and 90 degrees, this yellow region, which is between 90 degrees and 180 degrees, and this entire red region under the line, which is between 180 degrees and 360 degrees. We classify the angles purely based on these three regions. To classify the angles in this figure, we will consider ray OA as the initial arm for all angles. Any angle in the blue region is called an acute angle. Let's have another ray OB in the blue region. This angle formed here will be an acute angle. Any angle with its terminal arm between 0 and 90 degrees can be called acute. Any angle formed with its terminal arm in the yellow region will be an obtuse angle. Let this be another ray OD in the yellow region. This angle formed here is called an obtuse angle. That means any angle which has its measure between 90 and 180 degrees is called an obtuse angle. And any angle with its terminal arm in this red region is called a reflex angle. So if you have ray OF like this, then this entire angle starting from ray OA will be a reflex angle. So a reflex angle will always be greater than 180 degrees but less than 360 degrees. And if we have ray OG like this, then this big angle too would be a reflex angle. It's very simple. Any angle between 0 and 90 degrees will be acute. If it's between 90 and 180 degrees, it will be obtuse. And if it's between 180 degrees and 360 degrees, it will be reflex. One way in which you can remember this is by knowing that the letters A, O, and R are in alphabetical order. This recording from mathopenref.com will help us understand better. If the terminal arm lies anywhere between 0 and 90 degrees, it will be an acute angle. If we move the terminal arm anywhere in between 0 and 90, that angle will still be acute. At 90 degrees, it becomes a right angle. These two rays are said to be perpendicular to each other. Anywhere between 90 and 180 degrees, it will be called an obtuse angle. We see that a wide range of angles are covered between 90 and 180 degrees, and the angle is still obtuse. And at 180 degrees, we get a straight line or a straight angle. Anywhere between 180 degrees and 360 degrees, it will be a reflex angle. Any terminal arm in this entire region will result in a reflex angle. When 360 degrees complete one full rotation, and it will be called a full angle.
So this is a summary which you guys can take a screenshot of this, like acute angles will be less than 90 degree, right angle is 90 degree, obtuse angle is between 90 degree and 180 degree, straight angle is 180 degree, and reflex angles are between 180 degree and 360 degree, and full rotation or and complete angle or circular angle, or there are so many names of it, this is 360 degree. Okay, and if you want to see it like by drawing it, it will be looking like this. Okay, like up to 90 all are acute, up to 180 all are obtuse, bigger than 180 and smaller than 360 all are reflex angles, and a complete rotation will be 360. Okay, so let's go next. So now we'll be discussing the non-intersecting lines. Okay, two lines are said to be non-intersecting if they do not meet at any point. They are said to be parallel lines. Okay, and the examples are like this. Okay, distance between two parallel line is constant. Obviously, it has a fixed value which will be constant. Like from this point to this point, the distance will be same as the distance between from this point to this point. Obviously, it won't be looking like this. Okay, like this will not be an example of parallel lines because they are tending to be intersected in this point. Maybe they are not intersecting in this figure, but they will soon intersect. So that's why this is not an example of non-intersecting lines or parallel lines. Okay, next Next is linear pair, and talking about linear pair, adjacent angles which forms a straight line are called linear pair. So that means maybe the image has become a little rough here, so it will be looking like this. Okay, and if I draw a line here, so this will be called as a linear pair. Like they both will be making 180 degrees, so this will be called as a linear pair. Okay, so linear pair angles are both adjacent and supplementary. So why we are calling this adjacent? Because they are making in a same plane or same line. That's why we will be calling it an adjacent lines, and they will be forming a straight line. Okay, and together they will be called as the linear pair. Okay, next. So again the discussion, like wow, lines and angles are base for any shape. It's time to learn more about them. Okay. Hey, time. Yeah, clock shows different angles between needles as lines. Okay, just like we have already discussed it. It has the current time is 12:45 maybe, or 12:43 maybe. So they are also making an angle here. Okay, and the measurement of this angle will be, just I have told the formula, like every time is 30 degree, so it will be like starting from this, will be 7 8. So from a more than 240 degree and less than 270 degree, whichever will be the value of this time specifically. Okay. Now we will be seeing a video. Okay, let's skip this video or we will be discussing it later. Okay, so pair of angles like complementary angles, supplementary angles, and adjacent angles, and linear pair and vertically opposite angles. So these are all the types of pair of angles. That means here we have to need two angles to verify this or satisfy all of these formulas. Okay, so let's go further and discuss about it. Okay, so two angles here we are getting all the type of two angles like ABC and PQR or ABC or like this. Okay, so what are adjacent angles? Like we have already. Okay, so okay, so let's see a video of it. Let's watch the adjacent angles and you will be
Let's understand special pairs of angles, all of which are called adjacent angles. Consider this angle. We name it angle PQR. Now let's do something interesting. We draw a ray through vertex Q. Let's call it ray QX. And guess what? We already have two adjacent angles. This angle and this one. So angle PQS and angle SQR are called adjacent angles. Adjacent simply means next to each other. Since these two angles are right next to each other, they are considered adjacent angles. Also, adjacent angles have one common arm and a common vertex. In this example, ray QS is the common arm to both the angles and point Q is the common vertex. For two angles to be adjacent, all these conditions have to be satisfied. Now let's form an interesting figure. We draw angle ABC. We draw another ray from vertex B and call it ray BB. Now this figure looks similar to the previous figure. Here too, we have two adjacent angles. To make it a bit more interesting, let's draw another ray and call it ray BE. If you can find all the adjacent pair of angles in this figure, it means that your concepts of adjacent angles are clear. Remember, adjacent angles have a common arm and a common vertex. Pause the video for a moment and try to find all the adjacent pairs of angles. Okay, here we go. The first pair of adjacent angles I will produce in the figure will be these two, angle ABE and angle EBD. You can see that they have a common arm, ray BE, and a common vertex B. The second pair I will achieve is this angle and this angle, angle EBD and angle GBC. Most of us have got these two right. What about this green angle and this red angle? Of course, they're adjacent. They have a common arm BD and a common vertex B. So angle ABD and angle DBC also form an adjacent pair of angles. Are there any other adjacent pairs left? Now look at this red angle and this green angle. Yes, they're adjacent pairs too. They have a common arm BE and a common vertex B. So angle ABE and angle EBC are adjacent angles. What about the same green angle and this tiny red angle? We're talking about angle ABE and angle DBC. They are not adjacent angles. Yes, they have a common vertex, but they do not have a common arm. Another small condition we need to remember. Consider this green angle and this red angle. They have a common arm BD and a common vertex B. Are they adjacent angles? You've probably realized it's a tricky question. They cannot be adjacent angles as one angle is a part of the other. Angle EBD is a part of angle ABD. When we talk about pairs, we talk about different angles. So apart from these two conditions, remember that two angles cannot be adjacent if one angle is a part of the other.
Okay, so all the discussion about adjacent angles has been complete. So what we have learned that adjacent angles must have a common arm and a common vertex. Okay, so common arm is this and common vertex will be this. Like PQS and SQR will be a perfect example of adjacent angles. Okay, and for these cases, for these cases, ABE and EBD will be adjacent. EBD and EBC are adjacent. ABD and DBC is also adjacent, and AB and EBC are also adjacent, but ABE and DBC are not adjacent because ABE and DBC don't have any arm in common. Okay, so this part will be is a blank spot here which is not being considered in the angle. So that's why they won't be adjacent. And talking about the next one like ABD and EBD, ABD and EBD will not be adjacent because this part also the common part which is coming into the two angles. So that's why they are not making a complete angle here or making a same part double time in an angle. So that's why they won't be considered as adjacent angles. Okay. So let's go further. Okay. Okay. So we have already discussed about adjacent angles, and a pair of angles are said to be adjacent if they share a common arm and vertex. Okay. And all the discussion has been done about adjacent angles, and these all are the part of the video. And non-common arms of adjacent angles with the sum 180 degree. Okay, let's not play the video here. Okay, so if the sum of two adjacent angles is 180 degree, then the non-common arms of the angles form a line. Okay, so it's saying that for this image PQR is forming a straight line which will be PQS and SQR. So that means PQR will be 180 degree and only straight line forms 180 degrees. So PQR is a straight line. So this is a general theorem or a small theorem about this topic. Okay. So now we will be learning the complementary angles. It also has a video. I am not be playing the video because it's a very easy and common concept. So I will be not wasting time here. So sum of two angles which makes 90 degree will be called as the complementary angles to the another. Like 55 and 35 is making 90 degree. Like if I take pair like 45 and 45, the sum of 45 and 45 is 90, so they both will be the complementary angles of each other. Okay, like 70 and 20. Okay, and I'm 50 and 40. I'm only taking the proper examples of complementary angles, like which is been 0. Like I can take 78 and 2 degree as well, but angle 2 degree is very much smaller angle, so that's why I'm taking proper examples. Okay, and in exam also you will be given the proper examples as well for like this class. I mean, I can also take like 78.88 and 1.12 maybe. 1 point, sorry, it will be 12 degree, like, so it will be 12.8. Okay, so they will be also forming an complementary pair, but these are not the proper examples here. Okay, so these are the proper example like 70 and 20, 50 and 40, 45 and 45. Okay, so these are the proper pairs. Next, complementary angles. So the definition of complementary angle will be like this: a pair of angles are said to be complementary if sum of those two angles is equal to 90 degrees. Okay, so angles x and y are complementary angles if x plus y equals to 90. And the example will be like this. Okay, so what are supplementary and vertically opposite angles? It also has a video and I am not be playing it. Like vertically opposite angles are opposite angles with same vertex and have no common arm. Okay, so these two will be called as the vertically opposite angles. Okay, it has common arms like this, opposite angles in the same vertex, so vertex is the same and have no common arm. Okay, so they are not having any common arm. Okay, so we are vertically opposite angles are opposite angles with same vertex and no common arm. Okay, let's go further. So vertically opposite angles are equal. This is a theorem and this is a general formula as well. So you have to just remember this. Okay, like the measurement of this angle and this angle will be same. Like if it's 45 degree, it will also be 45. Okay. So let's go to the next, like supplementary angles. Okay, so a pair of angles are said to be supplementary angles if sum of those angles is equal to 180 degree. Okay, so just like the previous one, like complementary angles, angles x and y are said to be supplementary angles if x plus y is 180 degree. Like if x is 140 degree, y will be 40 degree. I can take like 160 and 20. Okay, I can take 180. Okay, and there are so many like 90 and 90 and all of that will be called as the supplementary angles. Okay, so now this is like a general sheet of sum of two angles 180 degree. Like these two are supplementary angles and ABC and ABD will be called as the linear pair as both angles are the supplementary angles. Okay, and we have already learned about the complementary angles. Like if I draw a right angle and draw two different angles, they will be called as the complementary angles. Okay, done. So and like complementary, and this is like a remember all type of thing, like C for complementary, C for corner, and corner makes 90 degree, and S for straight line, and straight line means supplementary angles. Okay, okay, what are the different angles formed by a transversal with two parallel lines? So let's watch the video of this.
Consider line B and line Q, which are on a plane. The lines are also parallel to each other, which would mean that they do not intersect or ever meet. And this is transversal R, which cuts the lines B and Q at two distinct points. In this video, we will try to understand the difference is formed by the transversal with two parallel lines. The transversal forms four angles with line P. Angles 1, 2, 3, and 4, and four angles with line Q. Angles 5, 6, 7, and 8. Let's move on to the first type of angles. If lines P and Q are parallel, then angle 1 will always equal angle 5. This angle here will be equal to this one. They are called corresponding angles. It doesn't matter how the transversal is placed. These angles will always be equal. On a new page, let us try moving the transversal around. Assume line A and line B are parallel to each other. And here's the transversal C. You can see that these two angles look equal. Now let's rotate the transversal towards the right. These two angles again seem to be equal. Now let's rotate the transversal towards the left. Angles become obtuse and are still equal. This tells us that the corresponding angles are always equal. Now let's go back to the previous page. Now let me ask you an interesting question. Look at the figure closely. Is this the only pair of corresponding angles? No, it isn't. We have three more pairs of corresponding angles. When a transversal intersects a pair of parallel lines, four pairs of corresponding angles are formed. 2 and 6 form a corresponding angles pair. So angle 2 will always equal angle 6. You can even look at the figure and observe that they are equal. Similarly, angle 3 will equal angle 7 and angle 4 will equal angle 8. These are the four pairs of corresponding angles that are formed. 1 and 5, 2 and 6, 3 and 7, 4 and 8. Angles 3, 4, 5 and 6 are interior angles because they are between the two parallel lines. And they are classified into two types. Let's understand the first type. Angle 3 and angle 5 form a pair of alternate interior angles. We know why they are called interior. Why exactly are they called alternate? If we have a round table with numbers 3, 4, 5, and 6 around it, then 5 is alternate to 3. That's because after 3, you skip one position and take the next. Similarly, 6 will be alternate to 4. In this diagram as well, to find alternate to 3, we skip one position and take the next, which is 5. And similarly, angle 4 and angle 6 are also called alternate interior angles. This was the first type of interior angles. The second type is a pair in which the angles are next to each other on the same side of the transversal, like angle 3 and angle 6. They are called consecutive interior angles. Look at the figure now. Do you see any other pair of consecutive interior angles? Yes, with the same logic, even angles 4 and 5 are consecutive interior angles. Remember, there are two types of interior angles, alternate and consecutive. For alternate, we skip one and move to the next. For consecutive, we take the one that's immediately next to it. And the last types of angles that are formed are vertically opposite angles. Angles 1 and 3 are called vertically opposite angles. Now, there are four pairs of vertically opposite angles. Apart from angles 1 and 3, we have angles 2 and 4, angles 5 and 7, and angles 6 and 8 as the other three pairs. Vertically opposite angles are always equal. These were the different types of angles that were formed when a transversal meets two parallel lines. On a new page, let's look at the beauty of these angles. Assume we have lines A and B which are parallel and transversal C which intersects them at two distinct points. As we already know, angles 1, 2, 3, 4, 5, 6, 7, and 8. Let us quickly analyze the relation between various angles formed. It's pretty simple actually. Angle 2 will be equal to angle 6 as their corresponding angles. And angle 8 equals angle 6 as it is vertically opposite to it. And angle 4 equals angle 8 because they are corresponding angles. Similarly, angle 1 equals angle 5 as their corresponding corresponding angles. The 7 equals angle 5 because they are vertically opposite. Angle 3 equals angle 7 because they are corresponding angles. So if lines A and B are parallel, we can see that angles 1, 3, 5, and 7 are equal, and angles 2, 4, 6, and 8 are equal.
Okay, so this one was the whole video about transversal, and transversal means when one line intersects two parallel lines or a pair of parallel lines and they make 1, 2, 3, 4, 5, 6, 7, 8 angles between them. Okay, so and for these angles, which are the corresponding angles and which are the vertically opposite angles, we have discussed it in this video, and which type of angles will be equal to each other is also being discussed in this video. Like 2 angle 2 and 4 will be vertically opposite, so they will be equal, and 6 and 8 are also vertically opposite angles, they will be equal. Also angle 2 and angle 6 will be equal, and angle 4 and angle 8 are also be equal. Okay, so this is the whole point of the discussion, and the application of this and application of all of this video will be having it here. Okay, so 3 and 4 will be called as the alternate interior angle, and 3 and 6 will be called as the consecutive interior angle. Okay, like these all are the interior, like 3, 4, 6, and 5, and 1, 2, and 7 and 8 will be called as the exterior angle, and 1 and 5 is corresponding angle like 1 and 4. So it's the similar way 4 and 8 will also be, and 3 and 7 and 2 and 6 also be. So this is just a discussion about this. So now we'll be having some proofs, like prove that if two lines are parallel to a line, then they are also parallel to each other. Okay, so I will not be playing the video here, like line B and line A. So 1 second please. Okay, okay, sorry for the interruption, guys. So in this theorem, like given line B is parallel, line B is parallel to line A and line C is parallel to line A also. Like A is parallel to B and B is parallel to C and also A is parallel to C. We have to prove that B line will be parallel to the C line. Okay. So A is parallel to B and C is parallel also to A. We have to prove that B will be parallel to C. So draw a transversal like D. So we have drawn it and line B is already parallel to line A. So that means that GIB and IJD, like GIB and IJD will be the corresponding angles, like these two angles will be corresponding. Okay, and line C and they will be equal, and line C will be is parallel to line A. So that means GIB is also equal to the IJD, like IJD, and sorry, GIB will be parallel to JKE. So we already had GIB, so GIB will be equal to the JKF. So line B and line C will be parallel. So this was just the discussion of this video. Okay, let's go further. So perpendicular transversal. Okay. So transversal, a line passing through two or more lines will be called as the transversal. Okay. Like this is a transversal and also this is a transversal. Okay. And this one is just like the measurement of the measurement theorem or the measurement of or proof of these of lines. Okay. And corresponding angles will be angle 1 and angle 2 will be corresponding angles. Okay, next, what is the sum of the angles of a triangle? Okay, and we already know that the sum of the interior angles of a triangle is 180 degree. Like the measurement of this angle and this angle will be 180 degree. Okay, next, the sum of angles is 180 degree and it's being shown like for all of this. Okay, next, how does the sum of angles of a triangle measure 180 degree? Okay, this is another video and I'm not be playing the video here, and in this video they have discussed all the interior angles and the exterior angles of all of this. Okay, so this is the relationship of exterior angle or sum of the interior angles in opposite. Okay, like 1, 2, 3 is 180 degree and 3, 4 will also be 180 degree because this is a linear pair which we have already discussed in previously. Okay, next, exterior angles of a triangle's example, like this is the example of the exterior angles, like the sum of exterior angles will be 360 degree because sum of interior angles of a triangle we know already that this is 180 degree, so the sum of exterior angles will be 360 degree. Okay, this was, you have to remember this as well. Okay, so now we have a alternate angle test. It has a video also here, so let's watch the video because I have already skipped so many videos.
Let us review what alternate angles are. Assume we have two lines, line A and line B on one plane, and another line C, which intersects the two of them. Lines A and B may or may not be parallel. Line C is called a transversal, and 8 angles are formed when a transversal intersects two distinct lines. four of which are interior. Angles 1, 2, 3, and 4. Angle 1 and angle 3 is one pair of alternate interior angles. And angle 2 and angle 4 is another pair of alternate interior angles. Here's the beauty of alternate interior angles. Even if one pair of alternate interior angles are equal, then lines A and B will surely be parallel. In this case, if angle 1 equals angle 3, or if angle 2 equals angle 4, then lines A and B would be parallel. Let's erase this and try to understand what the alternate angles test says. If a pair of alternate interior angles formed by a transversal of two coplanar lines is congruent, then the two lines are parallel. But we need to prove this. And the best way to prove anything in geometry is by representing it diagrammatically. We draw two coplanar lines and a transversal through them. Let one of the lines be line B. We can also call it line AB. This is line Q, which can be called line CD. This is transversal R, called line EF. As we can see, the transversal R meets the lines at 2 points. Let's call them points G and H. The only reason why we name each line and each point is because angles are involved. We can now call this angle AGH. We can call this angle here GHD, and so on. So what exactly are we proving out here? Before we find out what we have to prove, let us know the things that are given to us. The first thing that we know is the fact that lines AB and CD are coplanar. And we have one pair of alternate angles congruent. Angle AGH is congruent to angle GHD. This is all that we have. What do we have to prove? We have to prove that line B is parallel to line Q. By just looking at the figure, there's no obvious way to prove this. And as I mentioned before, when there is no obvious way, we try indirect proof. With the given data, let us assume that lines B and Q intersect. So if we prove this assumption wrong, then we will be successful in proving that lines B and Q are parallel. How would the lines look if they intersected? Let's redraw the figure. We draw line B, which is line AB like this, and we don't change the direction of line Q, which is line CD. The transversal R intersects line B and Q at points G and H respectively. This is how the figure would look like if the lines were not parallel. If the lines B and Q are extended, then they meet at point Z. They meet at point Z to form triangle GZH. Let me repeat what we aim to do here. We were given that angle AGH is congruent to angle GHD, and we have to prove that lines B and Q are parallel. So by using indirect proof, we make an assumption that lines B and Q intersect. And now our aim is to prove that this assumption is wrong. Because if lines B and Q intersecting is wrong, it means lines B and Q are parallel. Now look at the second figure closely. Focus on these two angles. Measure of angle AGH plus measure of angle ZGH will equal 180 degrees as these angles form a linear pair. Look at triangle GZH. The sum of all three angles of the triangle equals 180 degrees. Angle ZGH plus angle GHZ plus angle GZH will equal 180 degrees. Both these expressions equal 180 degrees. It means they are equal. Notice that angle ZGH is common to both the expressions, and so we can cancel it out. What we get is angle AGH equals angle GHZ plus angle GZH. Let's understand something very interesting now. If 7 is equal to 4 plus 3, we can surely say that 7 is greater than 4 and 7 is greater than 3. Basically, if as sum of two positive numbers, then that number is definitely greater than each of the numbers. So in this case, we can say that angle AGH will be greater than angle GHZ. And angle GHZ can be written as angle GHD. So we get angle AGH to be greater than angle GHD. But the given statement says that these two angles are congruent. So our assumption contradicts the given statement. So our assumption turns out to be wrong. And if line B and Q intersecting is wrong, then line B has to be parallel to line Q.
Okay, so this one was the alternate angles test, and the video is done. Okay, so what is the converse of the alternate angles test? So if you have already learned or understood the alternate angles test, so in similarly we can also prove for these pair of angles that they are also same. Okay, so let's go further. What is the corresponding angles test and its converse? We have already learned it before, and why we are all studying this, just because we have to show that the alternate angles are equal to each other. Okay, so alternate interior angles and vertically opposite angles, we have already tested about this. Okay, so what is the consecutive interior angles test and its converse? So this will be looking like this, and these all are the theorems, or maybe not theorem. It's all are the, like, you have to remember all of this, because when we will be doing the sum, we will be applying all the formulas from this. Okay. So now come to the concurrent lines. Three or more lines are said to be concurrent if all the lines intersect at the same point. Okay. So if I draw all lines here like this and they are all intersecting at this point or this point. Okay, so they will be called as the concurrent lines. Like for the cycle spoke, it's a cycle's tire or tube or whatever, and these are called as the spoke, and all spoke intersect in this point. Okay, and why we use uh, spokes in a cycle's tire? Because to keep it intact. Okay, so whenever, and you guys, maybe many of you people ride cycle, and whenever one or two spokes get broken, we have to fix this, because that's why the tire will be shaped, the shape of a round tire will be like this. Okay, and the cycle will be like a hinged up, may cause hinge and all of that. So that's why we use spokes in the cycle. Okay, so this is the concurrent lines examples, and let's go next. So yeah, this is the tire is like rounding, so we can see concurrent lines in a wheel. Okay, can you identify parallel lines and intersecting lines and concurrent lines in this Indian flag? Obviously, we have already celebrated the 15th August, and this is the flag. So you can generally tell. Okay, so parallel lines will be like these lines will be parallel. These lines are the intersecting, and the concurrent lines will be this and this. Okay, a ray has no endpoint. Is it true? So this is like a chapter test, what we have already learned. So a ray has no endpoint. Is it true? Yes or no? Yes, the ray has no endpoint. It has starting point but no endpoint. Okay, so it will be yes. Next, a line has a definite length. Okay, so a line doesn't have definite length, but line segment has a definite length. Yes, we generally, from the starting point, I have told that generally we sometimes mistakes lines as the line segment, but here they have specified it as the line. So line has a definite length, it will be no. Okay, a plane has length and breadth but no thickness. Yes, it will be yes. Okay, because if I am talking about plane, like this will be a plane, like this whiteboard is a plane. Okay, this wall is a plane. Okay, so for this whiteboard, thickness doesn't matter. Okay, for planes, thickness doesn't matter. For volume, it does matter, but for plane, it doesn't matter. So a plane has length and breadth, but no thickness. It will be yes. Next, line AB is same as the line BA. Obviously, it will be same. Yes, line. Yes, it will be yes. Two intersecting lines cannot be parallel to the same line. Okay, so if I draw it, two intersecting lines like these two intersecting lines cannot be parallel to the same line. Obviously, if they are intersecting, they won't be parallel. So it will be yes. Next, two distinct points always determine a unique line. Obviously, two distinct points always determine a line. Okay, so it will be unique. These 2 points, they will be unique. Okay, yes, linear pair of angle axiom. Okay, if a ray stands on a straight line, then the sum of the two adjacent angles so form 180 degree. Okay, maybe the image is not that much accurate or right. So if a ray stands on a straight line, then the sum of the two adjacent angles so formed is 180 degree. Okay, so it's a ray, it's being standed on a straight line, then the sum of the two adjacent angles, like if this one is an adjacent angle, so they will be forming 180 degree. Okay, next. Okay, converse, if the sum of two adjacent angles is 180 degree, then the non-common arms of the angles form a line. Obviously, they will be the non-common arm and they are forming a line. Okay. So, and now pair of angles. So, these all are the examples. Find the value of x and y and z. It is being given that this. Okay. Yes, you have to find. So, x and y will be equal and z will be equal as the sum of x and y. In the given figure, find the value of this. Okay, this one will be much more easier to find, like for 62 degree, it will also be 62 degree because this is the vertically opposite angle, and you have to find the value of 2 plus 3x, and 2 plus 3x may be this point. Okay, so you can generally find this. So 2 plus 3x is equals to 180 degree. 180 minus 2, you have to find it. In the given figure, find the value of x. Okay, so the value of x is 6x plus 2, it will be 180 minus 40, that is 140. So 6x plus 2 is 140. So x equals to, it will be 138 by 6. Generally, because, oh, sorry. 90 minus 40, because this is the 90. So 90 minus 40, we get 50. And 50 minus 2 is 48. So x is 8. So 6x plus 2 will be 50. Okay. So if you go by the formula, you will be getting 50. But if you don't just follow the complementary angles formula, so if this one is 40, this one will be 90 minus 40. So that is 50. Okay. So in the given figure, lines intersect at O. Obviously, this is O. If POY is equals to 90 degree, then A is to B equals to 2 is to 3, and find, you have to find 6. So let's to see if this one is 90. If this one is 90 degrees, so A plus B will also be 90 degree. Okay, because this is forming a linear pair. Okay, and if A plus B is 90, so I can take A as x and B as 90 minus x. Also, B plus C is forming 90 degree, 180 degree. A plus B is 90 and B plus C is forming 180 degree. Why? Because it's having a linear pair. So A plus B is 90. We don't need this. B plus C is 180 degree. And if this is 180 degree and this is already 90 degree, so we have to just find this one. So 90 plus A plus B plus C. So 90 plus A plus B plus C plus something is equals to 360 degree. Okay. So this one is A is to B equals to 2 is to 3 is being given. So this one will be 90 degree and it will be minus 90 degree. So we will get this point. Okay. So 2 is to 3 will be 20 is to 30. So let's verify this. Oh no. 2 is to 3 will be, 60 is to 30. So A is 2, so that means it will be 30, and B is 3, that means it will be 9. 1 is to 2 वाला है. So if A by B equals to 2 by 3 and 2 by 3 is 5, so A will be 2 by 5 into 90 because A plus B is 90. So it will be 36 and B will be what? 3 by 5 into 90. It will be 54. Now let's verify this. This is already 90 and these two are making 90. If this one is 90 and this one is 180, so it will be 180 minus 54, and the answer you have to subtract. Okay, done. Next, in the given figure, PQR is PRQ, then prove that PQS equals to PRT. Okay, if PQR is equals to PRQ, PQR is equals to PRQ, then prove that PQS is PRT. Okay. So this will be a linear pair and this is also a linear pair. If these two are same, so 180 minus PQS will be same as the 180 minus PRT. So from this point we can tell that PQS will be same as the. This is like a one shot or in one line proof of this theorem. Okay, let's go to the next. These all are the pair of angles sum. It is given that XYZ is 64 degree and XY is produced to a point P. A ray YQ bisects ZYP. Draw a figure from the given information. Find XYQ and reflex of QYP. So XYZ is 64 degree and XY is produced to point P. XYZ this a ray YQ bisects ZYP. ZYP and YQ. It's Q. So the figure has been drawn and we have to find XYQ. So this line you have to find. So XYZ is 64 degree. Okay. And it will be, and if it's 64 degree and the total is 180 degree, if this is 64, this will also be 64. So 64 and 64 will be 28. So total is 180 minus 128 will be the answer. Okay. Okay, angles by transversal. So these all are the co-interior angles, corresponding angles, alternate interior angles, and co-exterior angles. These are all the lines which are being formed by the transversal. Okay. Yes. So these will be called as the co-interior angles because they are in the interior and they will be equal to each other. So that's why we will be calling it co-interior angles. Okay, interior angles on the same side of the transversal are called as the co-interior angles. Next one, also called consecutive interior angles or allied interior angles. So these are the different name of this. Okay, next. If a transversal intersects two parallel lines, then each pair of intersecting angles on the same side of the transversal are supplementary. This is a big theorem, and the proof of this theorem maybe it's not included in your syllabus. So you have to just remember the pair of interior angles of the same side of the transversal are supplementary. Okay, so that means these two lines will be supplementary, that is 180 degree. Okay. Now, corresponding angles, the angles which are non-adjacent and lie on the same side of the transversal, of which one is interior and another is exterior, are called corresponding angles. Okay, just like for these two and these two. Okay, they are non-lying in the same plane or non-adjacent side, and in one transversal, one will be interior and one is exterior. They will be called as the corresponding angles. Okay, and it also has a theorem: if a transversal intersects a pair of parallel lines, then each pair of corresponding angles are equal. Obviously they are equal. Okay, now alternate interior angles. So alternate interior angles are these two and these two. Okay, the angles which are interior and lie on the opposite sides of the transversal are called as the alternate interior angles. Okay, so it also has a theorem: if a transversal intersects two parallel lines, then each pair of alternate interior angles are equal. Okay, so the theorems, you have to just check the book that is the theorem's proof has been in your syllabus or not. If not, then just you have to just remember this. Okay. Co-exterior angles. Exterior angles on the same side of the transversal are called as the co-exterior angles, like for these two angles and these two angles. Also called as the consecutive exterior angles or allied exterior angles. Okay. Theorem: lines which are parallel to the same line are parallel to each other. Obviously, lines which are parallel to same line are parallel to each other. Okay, so that means if this line is parallel to this, so that means this line will also be parallel to this. This is a very, easy one to guess. Okay, ways to prove two lines are parallel: showing a pair of corresponding angles are equal, showing a pair of alternate interior angles are equal. Okay, showing a pair of interior angles on the same side of the transversal are supplementary. Okay, why we are all studying this? Because it will be beneficial for different chapters, like for quadrilateral and for rhombus and all of that. To proving those, we have to learn the basic formulas of this, like midpoint theorem and all of this. Okay, ways to prove two lines are parallel. Okay, in a plane showing both lines are perpendicular to the same line, or showing both lines are parallel to a third line. Okay, so that means for this, if this line is parallel to this, we have to show that this is parallel to both. So we can say that these three lines are parallel to each other. Okay, in a plane showing both lines are perpendicular to the same lines. Okay, so if I take a plane here and a plane here and take two lines and show that they are forming a perpendicular, so that we can prove that these two lines will be parallel, obviously. Okay, in the figure below, AB is parallel to CD, CD is parallel to EF, and X and YZ equals to 3 is to 7. So we have to find X. So to find X, AB is parallel to CD and CD is parallel to EF, and Y is to Z is 3 is to 7. So these two, this will be equal to this, and if this is 3 and this is X, so you have to find X. Oh, so if I take, these two will be 180-degree. So if I take 3x, sorry, take this like 3a, y is to z equals to 3 is to 7. Take y as the 3a and z is the 7a. Okay, so x plus y equals to 180. So y means 3a, so x plus a equals to 180-degree. So x will be 180 minus 3a, and we already have z, and z will be equal as x, so that means it will be same as the 7a. So 10a is equals to 180-degree, so a will be 18. Okay, so it is 54-degree, 126-degree, and it will be, the value of x will be 18-degree. Okay, in the given figure, OA is parallel to CD. Find the value of x. OA is parallel to CD, so we have to find the value of x. Like if this one will be equal to this one, and this one will be equal to this one, so x equals to, it will be 20-degree. Okay, you guys can try it at your home. In the given figure, PQ is parallel to RS, MXQ is 135-degree, and MYR is 40-degree. We have to find the XMY. So the XMY will be same as XMY. So if this one is 35, this one will be also, this one will be 180 minus 35. Okay, and if this one is 40, so this one will be 180 minus 40. Okay, so if these two are like this, so we already know that they will be making 180-degree, and if they are making 180-degree, this one will be like a reflex angle, and this will be 360 minus, sorry, not 360, it will be 40 minus, the m will be what? The m will be 180-degree. Oh, sorry. So it will be 360 minus 240. Okay, that's being done. Next, the angles of a triangle are 2x, 3x, and this. Find the value of x of the measure of the each angle of the triangle. Obviously, so 2x plus 3x plus 5 plus 4x minus 14 equals to 180 degree, because from the angle sum property we know that sum of three angles is 180 degrees. So here we are having 4 and 2, 4 and 2 6, 6 and 3 9, 9x minus 9 equals to 180 degree. Okay, yes, so 9x equals to 189 by 9. So x equal to, it will be 189 by 9. So it will be 21 degree. The measure of each angle will be 42, 63 and 5, 68, and 84 minus 40 will be 70. So these three will be the measurement of each of the angle. Okay. Next, exterior angle property. If the side of a triangle is produced, then the exterior angle is formed equal of the sum of two interior opposite angles. Okay, so here we have to find the x. So it will be 70 minus 180. Okay, so this total will be making 180. So 180 minus 50 minus 60. That will be 70. So this is 70. 70. So if this one is 70, it will be 110, and check if I add these two, it will be having 110. Okay. Next, find the values of x and y in the given figure. So y will be 40 degree because 140, 180 minus 180 minus 140 equals to 40. So y's value is 40. Okay, if y's value is 40, then this value will be 110. If this one is 110, this one will be 70. Done. Okay, so that means 30 plus 40 will be same as the 70. Next, find the value of x from the given figure. Okay, so this one is for you guys. You have to do it at your home. I'm just giving you a hint. Like this one will be 180 minus 135. It will be 180 minus 135, and this one will be 70. 180 minus 110. Okay, and if you add these two and subtract it from 180, so you will get the value of x. Okay, this one is the general process, and if you can like cross, try to do a back calculation from this to get 110, like from adding this. Okay, so this one will be homework for you guys. Next, okay, an angle is one third of its supplement, find its measure. Okay, these all are the practice questions you have to do in your home. Like, an angle is one third of its supplement, find its measure. So if an angle is x and its supplement will be 180 degree. Okay, so 54. Okay, sorry guys for the interruption. Okay, so 3x plus 4x, and it will be, yes, 135 degree, and another will be, and another will be 45. Okay, so done. Next, supplement of an angle is one third of its angle, find its measure. So we have already done it. An angle is 28 degree less than its complement, find the measure of the angle. So it's a very much simple one. So 90 minus 28 degree. Okay, so you can solve this like, if one angle is x, another will be x minus 28, and sum of these two is 90. So 2x minus 28 equals to 90, and you have to solve this for x. You guys can do it, Okay, next. Next, two supplementary angles differ by 48 degree. Find the angles. So if one angle is x, take one angle as x and another angle as x minus 48. Okay, and sum of them will be 2x minus 48 equals to 180. And you can solve this and to find the value of the angles. Okay, next. Okay, 1/5 of the supplement of an angle is twice the complement of the same angle. Find the measure of the angle. 1/5 of supplement of an angle is twice the complement of the same angle. Let the angle be x. Okay, and 1/5 of the supplement is twice of the complement of the same angle. So twice of the complement of the same angle. Okay, so this is done it right. 5x plus 1 6x by 5, 1/5 of the supplement, that means let the angle be x, and 1/5 of the is 180 degree. Okay, and twice of the complement, that means so this one. So from this two one, you just can find the value of any one. Okay. Next, if complement of an angle is supplement of the thrice of it, find the measure of the angle. So if complement of an angle is supplement of the thrice of it, so maybe it will be 60 and 30. Okay, cos 90 plus 90, 6. The measurement will be 30 and 60. Okay, these type of question generally come in the MCQ, and you just can simply do an option test to find it. And if you have to find this, then you have to do it like the linear equation for two variables method, like taking x and y as the two variables and all of that. So before trying to doing that, you just can take general example of 30 and 60, 45 and 45 and all of that. Okay. How many pairs of adjacent angles are formed when two lines intersect in a point? Okay, so there will be one pair. One pair. None. If two interior angles on the same side of a transversal intersecting two parallel lines are in the ratio 2:3, then find the measure of the larger angle. It will be if two interior angles on the same side of the transversal, it will be like if I take 2x plus 3x equals to 180 degree. So x equals to 72 and the 108, because we already know that sum of two interior angles is always 180 degree. So that's why it will be 72 and 108. Okay, a wheel has six equally spaced spokes. Find the measure of the angle between two adjacent spokes. Okay, six equally. So it will be looking like this. If this one is a cycle and it has six spokes, one, two, three, four, five, and six. Okay, and we generally know that each spoke will be 360 by 6, 30 degree. Okay, so the angle will be 30 degree between each, equally spaced. Yeah, our in this figure it's not being equally, but it will be 360 by 6, so it will be 30 degree. Oh, sorry, not 30 degree, it will be 60 degree. 60 degree spoke. 360 by 6 will be 60. Okay, done. Find the measure of angle y. Find the measure of angle y, because it will be 3x plus 2x plus y equals to uh, in here 2x. Okay, so this one will be, if this one is 3x, this one will also be 3x. So 3x plus 2x plus x will be 6x equals to 180. So x equals to 30. And for x equals to 30, 3x plus 2x, that means 3 3s are 90 plus 60 plus y equals to 180. So y equals to, it will be 30 degree. So 30 degree will be the answer, measurement of y. So y will be 30 degree. Okay. How did I do it? 3x will be same as the 3x, because this will be the vertically opposite angles, and 3x, and from that I can find the value of x, and 3x plus y plus 2x will be 180 degree, because they all are in the linear pair, and from that we can find the value of y. Okay. Find the measure of angle x. You guys can just do this, like if this one is 65, x plus 20 plus this one will also be 65, and if this one is 65, this one will be 180 minus 65. So 180 minus 65 plus 20 plus x equals to 180 degree. So x equals to, I can find the value of 180 degree. Okay, so it will be 85 degree. Okay. Now, angles forming a linear pair are supplementary. Is it true or not? It will be true. Yes, they are supplementary. If two adjacent angles are equal, then each angle measures 90 degree. Adjacent angles are equal and they make 180 degrees. So yes, they will be 90 degree each. Next, angles forming a linear pair can both be acute angles. No, they can't be. No, because they can't be acute angles, because they have to form 180 degree. Okay, so one can be acute angle, but not both of them. It is a no. If angles forming a linear pair are equal, then each of these angles is of measure 90 degree. Obviously, we have already discussed it. It will be yes. Next, a ray stands on a line, then the sum of two adjacent angles so form 360 degree. A ray stands on a line, then the sum of the other two adjacent angles so form 360 degree. It will be no, because to make it, to prove this, if a ray stands in a line, then sum of the other two adjacent angles will be 180 degree, not 360 degree. Okay, so it will be a no. Okay, so done. So that's it for the chapter. I hope you guys have enjoyed the video. Don't forget to like the video and stay tuned with Fun Scholar. Goodbye.